chain of responsibility pattern allows building a chain of objects to handle a request. A request is passed through a chain of handlers, each capable of either handling the request or passing it to the next handler in the chain. So to understand this, let's go through an example where we first create a simple naive solution, then refactor it into something more maintainable using the chain of responsibility pattern. So let's say that we have a web page that contains some information that only admins of the website can access, such as a page that allows an admin to manage the website's users. For example, create new users, get information, update user information, etc. So say that a user makes a request to the website server, but before returning the web page, the user's data must be validated. So for example, we could trim any white space around the user entered data. We need to authenticate the user, so for example check their username and password are correct, and then log some information onto the server about this request. And if any of those steps fail, then access denied is returned to the user. So here is an illustration. So we have the user's request here, which goes to the server, which validates, authenticates and logs some information. And if any of these steps fail, so if the authentication fails, then then access denied is returned to the user. Otherwise, we can return the web page to the user. So let's now code up a straightforward solution for this example. So I've created a new folder called Chain of Responsibility for this example. We're going to first create the HTTP request class. So in here we need four fields. So the first two fields are going to be the user input fields, so that they are going to be username, and we're also going to create a second field for the password of the user, and these are going to be sent with the HTTP request. And we're also going to provide a couple of other fields, so these are actually going to be C# properties, and the first one is going to be validated username, and that needs to be a string. And the second one is going to be validated password. Okay, so when the username and password pass through validation, then these fields will be populated with the validated username. For example, if username is a string with some white space at the front, then the validated username will just be this without the white space. Okay, so it's essentially cleaning up the user input data. So let's also create a constructor so that the username and password can be set. And we'll also create a getUsername method. And also a getter for the password. Okay, so that's everything we need in our HTTP request object. So let's also create a class for the validator now, which is going to validate our user input data that is attached to this request object. So let's call this validator, and we'll have a method called validate, and this takes the HTTP request object, and let's actually get the username and password from the request object. And let's also get the password, and then we're just going to do some simple validation, and in this case we're just going to trim the white space around the input strings for username and password. So to do that, we can call username.trim and password.trim, and then we can set that to the validated username and validated password on the request object. Okay, so that's all we need to do in our validator class. Now for the authenticator. So once the request has been validated, we can pass it to the authenticator class. So let's create that class now. And let's get the username and password again. And we're just going to keep it simple here, and we're just going to check if the username is equal to Danny and the password is equal to 123, and if so, this will return true, meaning that the user has been authenticated. Okay, so that is everything we need for the authenticator class. And finally, the final step, once we've been through validation and authentication, we can perform some logging. So let's create a new class called logger. And in here we will provide a single method for logging to the console. Okay, and finally we need to create a web server class. So let's go ahead and do that. And this needs to have a method called handle, which is going to handle the request. So let's go ahead and create the handle method, and this is going to take a HTTP request. Okay, so now what we can do is we can actually put everything we have done together. So first of all, let's validate the request. And we can call the validate method on the validator. And we can pass the request. So that will populate the request object with the validated username and password. So in our case, we're just trimming the username and password. And we can now create the authenticator. And for this, we can call authenticator.authenticate. And again, we can pass the request object. So in a sort of real web server, we'd perhaps do something like throw an error if the user wasn't authenticated, or maybe we could return a web page with access denied, something like that. But just to keep things simple for now, we're just going to call the function, call this authenticate method, and not worry about whether it's true or false. Okay, and then finally, we're going to create a logger object, and then we're just going to log. And in here we pass the request object. Okay, so that's everything we need for now. So now let's have a look at how we would actually use this solution in a client. So first of all, let's create our web server. And let's also create our request object. And it should be this one. And I'm going to pass the username and password into this. So this is kind of like our user input data, or perhaps some data that was stored in the user session. And this is the username and the password, and in this case this would actually authenticate the user, because we want to check if the password and username is Danny and 123, and it is in this case, so that would be an authenticated user. And then we can call the server.handle method, and we can pass the request object. So let's run this and see what we get. Okay, so everything seems to be working okay. The log file has logged to the console, so that all seems to be working okay. Now this seems like an okay solution. It's pretty straightforward. However, there are some problems with this approach. So with this solution, the order of operations, so if we go into our main sort of web server class, which brings everything together, we can see here that the order of the operations, so we have validate, authorize and log, are hard coded inside the web server class. So if in the future we wanted to disable login or authentication for certain scenarios, certain routes, certain web pages, we cannot do so. We'd have to come back and modify the code in the web server class itself. And this violates the open close principle, because if we wanted to change the order of the steps or add an extra step, we'd have to modify some existing code. And the chain of responsibility pattern solves this, as we can build a pipeline with a chain of objects for processing a request, and the request can be of any type, not just a HTTP request. Another issue with this solution is that because of the new keyword, so you can see here we're using the new keyword 3 times within this method inside the web server class, we can see that the web server class is tightly coupled to these concrete validator, authenticator and logger implementations. So to solve this, we could extract interfaces from these classes and have our web server talk to iAuthorizer, iValidator and iLogger interfaces. And this would make our web server class more flexible, because if we wanted to use a different type of validator or a different type of authenticator, we could then pass that into the web server so that it's not sort of tightly coupled to these concrete implementations. So let's now try to solve the problem using the chain of responsibility principle. So instead of having all of our request processing logic inside of the web server.handle method, we can create a processing pipeline or a chain of objects. So here you can see that we have our incoming request, our HTTP request, and then we have a sequence of objects. So first of all we have the validator, which validates the request, and then this points to the authenticator and passes the request to the authenticator, and if it's successful, the authenticator points to the logger and passes the request onto the logger, and if that is successful, then the user can be directed to the web page, or the web page is returned to the user. So here each object only knows about the next object in the chain. So for example, validator only knows that the next object in the chain is authenticator. It doesn't know anything about the logger object, for example. So first a request is passed to the first object in the chain, which in our case is the validator, and if this request is successful, it passes the request to the next object in the chain. If it's not successful, it will stop processing right there, so that the other objects aren't used. So here's the UML for the chain of responsibility solution, and you can see here we have our web server, which has a handle method which takes the request, and a web server is composed of a handler which is an abstract class with a setNext method for setting the next handler. So for example, validator, we would set the next handler as authenticator, and then for authenticator we would set the next handler as logger. And each handler needs to implement a handle method which takes a request object. Okay, so we have an abstract class called handler, that has a reference to itself. So it has a field called next of type handler. So with this, each handler can know about the next handler in the chain. And this is essentially a linked list data structure. And the handle method is an abstract method because at the time of implementing this class, we don't know how to handle a request. We determine or implement this in our concrete handlers, which are, in our case, validator, authenticator, and logger. So web server has a reference to the first handler in the chain, okay, and that is the validator. Okay, so when the web server sees the request, it can pass the request to the first handler in the chain, which in our case would be the validator handler. So you should also note that web server is not talking directly to the concrete handlers, it's talking to a handler interface. So it's completely decoupled from the concrete implementations of handlers. And this satisfies the open-close principle because if we want to, for example, remove login, we don't have to go to the handle method on the web server and change its implementation. Also, if we want to add a new process, we can create a new class that extends handler, then add it to our chain. We extend the code, but we don't modify any existing source code. So here is the gang of 4 implementation of the chain of responsibility pattern. So we can see here we have our abstract handler class, which has a next field of type handler, okay, so which is the same type as itself. And we also have a set next method, which takes a handler, and this is how we can set the next field. And we also have a handle method, which takes a request object. And in this handle method, we can see that we check if next is not null, then we call the next handler's handle method and pass the request. We then have our concrete handlers, which inherit from this handler abstract class. And then we have our client here. So this is how our client can create a chain using this solution. So we can see here we're creating a handler 1, handler 2, handler 3. And these are concrete handlers that it's creating here. So handler 1, handler 2, handler 3. You can see we're using the new keyword. And then we can set up our chain. So we can call h1, so handler1.setNext. And what comes after handler 1? It will be handler 2. So we pass handler 2. And then for handler 2, we call setNext and pass handler 3. And then to initiate the request, we get our first handler and call the handle method and pass the request object. So let's now implement this solution in code. So first of all, let's create the abstract handler class. So first of all, let's create the abstract handler class. And this needs to be an abstract class. And we need to store a reference to the next handler in the chain. So let's create a field of type handler, and we'll call this next handler. Okay, so let's create our setNext method as well. And this is going to return a handler as well as accept a handler. And we're just going to set the next handler equal to this handler. So why would we actually return a handler from this setNext function, or method I should say? Well, the reason for that is because returning a handler from this setHandler method allows us to link handlers in a convenient way. So for example, we could call handler 1, so h1, and if it lets me do it, let me just do it as a string, so h1, and it will be set next, and we could pass h2 in here, so handler 2, and then because this set next method is returning the handler, we can then simply just keep on chaining these set next methods, and very conveniently can create our chain of responsibility essentially. Okay, so we can do it all sort of on one line rather than having to do it on multiple lines, so it's nice and convenient. And that is why we return handler from set next. And if that doesn't make sense, it will make more sense when we actually use this solution in the program.cs file. So bear with me for now. So next up, we want to create our sort of handle template method. So let's go ahead and create that. And this is going to take a HTTP request. So what we want to do now is we want to have an if statement. So we're going to say if do handle request, and this should be do handle, and we're going to create this method in a second. So if do handle request, then we can return from this handle method. So what this essentially means is if do handle returns true, we return early and the request processing ends here. Otherwise, we are going to check if the next handler is not equal to null, then we are going to call the next handler .handle method and pass along the request object. So now let's actually create this do handle method. So this is actually going to be an abstract method that returns a boolean and takes a HTTP request object. Okay. So this do handle method is going to be implemented in the concrete handlers. So this is going to make more sense shortly. So again, bear with me. So let's now create the concrete handler classes. So first of all, let's create the validator. And this needs to extend the handler class. So let's implement this abstract class. So we need to create this do handle method. And in here, we're essentially doing what we did before. So we get the username and the password from the request object, trim the white space, and set the appropriate fields as we did before. Okay. Now this time we also need to return a boolean value. So what should we return here? So returning false means that we are not done processing the request, so the next handler in the chain should be called, and returning true ends the request processing here. So in this case we should always return false, because there's no reason for the request to stop processing at this point. So here we can simply return request. Actually, what we can do is we can return true if the validated username or the validated password are empty strings. So if the user provides an empty string for username or password, then we will stop the processing here, and the user will not go through to the web page essentially. So let's go with that. So request.validated username equals empty string, or request.validated password equals empty string. So essentially, if we return false here, then we are not done processing the request. So if the user has provided a username or password, a username and password, then we will continue processing the request. Otherwise, the request ends here if the username or password is not provided. Okay, so now let's create our authenticator class. And this again needs to inherit from the handler. And for this one, I'm just going to copy and paste in what we had before. So you can see here, if the username equals Danny and the password equals 123, then in the brackets will be true. However, true would mean ending the request. So what we actually need to do is stick an exclamation mark to negate, or make this the opposite of what the result in the brackets is. So if the username is Danny and the password is correct, then we actually are going to return false, and the request will continue on to the next handler. Okay, so that's what we want to do here. And just to remind you why that is the case, it's because in this sort of template method, this handle method, we are checking if do handle is equal to true, and if it is true, then we end the request. Okay, so if we want to continue to the next request, the next object in the chain, then we need to return false from this do handle method. So that's how that works. And finally, we're going to create our logger object. And again, we need to extend the handler class and implement all of the methods. And this is a very simple method. All we're going to do is log to the console and just return false to continue with the request. So essentially this means that this sort of step in the chain can never fail. Basically, it's a sort of fail-proof handler. Okay, so now let's have a look at how we code up the web server class. So let's create the web server class. Okay, so in here we need to store a reference to the first handler in the chain. So let's do that. And we can pass the handler in the constructor. Okay, so let's also provide a handle method. Just like we did before, it takes a HTTP request and we're just going to call handler.handle and we pass that request object. Okay, so now let's actually use this solution in the client. So let's get rid of all this, and we can say var validator equals new validator. Let's see, I think it should be this one, yeah. And let's also create an authenticator. Authenticate. Sorry, having some spelling issues there. And logger equals new logger. Okay, so now what we can do is, if you remember when I mentioned earlier that we are returning the handler from the set next method, and because we're doing that, we can just chain everything together in one line. So we can call validator. Now this is going to be our first object in the chain, and we're going to set next. So the next object needs to be the authenticator, so that's our next step in the chain. And because the set next is returning a handler, we can just chain on the next handler, and that is going to be the logger. Okay, so we can do that all nice and conveniently in one single line of code. Okay, so now we can create our server, and we pass the first step in the chain, the first object in the chain, which is validator in our case. And then let's create a HTTP request. And that's not what we want. Let's see. I think we actually need to create this HTTP request object inside of our new good solution folder. So let's actually let's create this HTTP request object, because we forgot to add it to this new good solution folder. And this is actually going to be the same, exactly the same as what we had beforehand. So let's copy and paste everything that we have inside here, and we'll paste it inside of here. So hopefully that fixes the issues that we had before. And in here we need to provide a username. So first of all, let's actually pass some credentials that are correct. So this will pass the validation and authenticator steps. So let's actually handle this request now by calling the server.handle method, and we can pass this request to the server handle method. So let's just check what happens here. And you can see that we validate, authenticate and log, so it passes through all of the steps no problem, and we can return the web page to the user. So this is like a successful request. So let's actually test what happens if we create a request with an invalid password. Okay, so if we give it a correct username but the password is incorrect, okay, so the password needs to be 8123 to pass, and then if we call server.handle request2, let's see what happens here. So let me comment this out just to make it clearer what's going on with this new request. So we can see here that we validate the request, no problem, and then we authenticate the request, but because the password is incorrect, the chain stops at the authenticating step and it never reaches the log step. Okay, so that is working perfectly. Now let's see what happens if we provide an empty username and password, so the user hasn't actually provided any credentials. As you can see, it just goes to the validating step. The validating step fails because we have two empty strings and the user is never authenticated. That we never get to the authentication step in the chain. So this is working exactly as we want it to. So here we now have a flexible solution that makes it very easy to change the order of processes. So as you can see, we can easily change the order of processes in the client without having to modify any code in the web server class. So this is super flexible and easy to change the order of processes. And it's also easy to add or remove processes without having to modify any existing code, which satisfies the open-closed principle.